Hello, today I'm going to show you how to calculate the integral of x2 plus x plus 1 divided by x2 plus 1 with the power of 2 dx. Okay? To solve this integral, you have to express this rational function as the sum of partial fractions. So if you write x2 plus x plus 1 divided by x2 plus 1 with the power of 2 will be equal to ax plus b divided by x2 plus 1 plus cx plus d divided by x2 plus 1 with the power of 2. Okay? Therefore, x2 plus x plus 1 will be equal to ax plus b times x2 plus 1 plus cx plus d. Okay, therefore x2 plus x plus 1 will be equal to, that will be ax3 plus ax plus bx2 plus b times 1 plus b plus cx plus d. Okay, therefore x2 plus x plus 1 will be equal to ax3, that's this term, plus bx2, that's this term, plus a plus c times x, that is this two term, plus b plus d, which is the constant. Okay, so when you compare each side of this equation, you can conclude that 1, the constant, is equal to b plus d. The coefficient of x, that is 1, is equal to the coefficient of x on this side, that is a plus c. And then the coefficient of the x2, 1 is equal to b, and a is equal to 0, because you don't have x3 on this side of the equation. So if you solve this equation, you will end up, so a and b, you already have the value, and you will get c will be equal to 1 and d will be equal to 0. Okay, so all you need to do here now is to substitute these parameters into this basically equation. Okay, so here therefore you can basically write this integral, the integral of x2 plus x plus 1 divided by x2 plus 1 with the power of 2 dx will be equal to a is equal to 0 here, b is equal to 1, therefore this will be integral of dx divided by x2 plus 1 plus the here c is equal to 1, d is equal to 0, therefore this one will be equal to integral of x dx divided by x2 plus 1 with the power of 2. Okay, so this integral basically will be tangent minus 1x, but this integral, to calculate this integral, you need to use the substitution rule. Okay, so if you let's first calculate this integral. For the integral of x dx divided by x2 plus 1 with the power of 2, you can basically define x2 plus 1 as u, therefore 2x dx will be equal to du. In other words, x dx will be equal to 1 divided by 2 du. Okay, so now you need to substitute these equations into this integral, and if you do that, you can rewrite this integral as, instead of x dx, here I have x dx, I simply write 1 divided by 2 du, and instead of x2 plus 1 with the power of 2, I write u2, because x2 plus 1 is u, therefore this will be u2. And the integral of du over u2, we know it is equal to minus 1 divided by u. And there is a 1 divided by 2 here, therefore this one will be equal to minus 1 divided by 2u. Okay? And u is equal to x2 plus 1. x2 plus 1 times 2. Okay, so this is basically the integral of this term, and the integral of this term we know, therefore this integral here will be equal to integral of dx divided by 1 plus x2. We know it from table of integral, that is equal to tangent minus 1x plus the integral of the second term we already calculated here, that is basically is actually minus 1 divided by 2 times x2 plus 1 plus c, which is the constant of the integral. Okay, and that is the solution to our integral. Okay, I hope you found this video helpful. If you are interested, please feel free to subscribe to this channel so that you get updated when I upload new videos. Thank you.